Hello, my name is Youngchar John, and I'm presenting combustion characteristics of LFG in CVCC according to the hole size of the pre-chamber spark plug. The table of contents is first, introduction, second, related works, third, proposed method, fourth, experimental results, last is conclusion. Interest and importance of gas energy source are increasing as alternative and renewable energy source because it emits less environmental pollutant than fossil fuels. Among them, the application of landfill gas through the development of refining technology and capture technology has been actively promoted. Methane, a major component of landfill gas, is mainly used in power plants around landfill because it is stable as a gas engine's fuel. However, due to the combustion characteristics of gas fuel, it is difficult to start combustion with current ignition technology, which hinders the expansion of power plants using the gas fuel. So we need ignition technology to solve this problem. The structure of the pre-chamber is the same as shown under the picture. In the case of spark plugs and engines using gas energy source, a lot of research is underway to improve combustion performance. Research on pre-chamber and torch ignition is underway, but no research has yet been conducted on combustion characteristics according to the hole size of the pre-chamber. The diameter was selected as 2.0 and 2.5 and 3.0 according to a prior study, and other structures were constructed to suit the experimental device. The experiment method was conducted using CVCC. CVCC is constant volume combustion chamber. To check the flame propagation process, combustion pressure, and air-fuel ratio, and LFG combustion. The fuel used for combustion is methane, the main ingredient of LFG, and the experiment was conducted after injecting methane and compressed air into the combustion chamber. The experimental condition generated an ignition source of waste type ignition coil using the existing SI method. Air-fuel ratio is from 0 to 0.9 to 1.8. The initial compressed pressure is 3 bar. The temperature was maintained at 25 degrees so that the test results were not affected. Fuel is methane, and pre-chamber hole size is 2.0, 2.5, and 3.0 millimeters. The first picture shows flame propagation in air-fuel ratio 1.0. with the fattest flame propagation speed at pre-chamber vent diameter M2.0, and the flame extension was found to have occurred completely at approximately 25 milliseconds, with full ignition at 37 milliseconds. In conventional plugs, the band diameter M2.5 and M3.0 produced complete ignition at 29 milliseconds and 33 milliseconds, respectively. The last picture shows the flame propagation speed at air-fuel ratio 1.8 and identified the fattest at the outlet diameter M3.0. We found that ignition was complete at 109 milliseconds in diameter M3.0 and M2.5 at 116 milliseconds and M2.0 at 120 milliseconds. Conventional spark plugs have been verified to complete the ignition at 160 milliseconds. For combustion pressure, both the existing plug and pre-chamber were measured at the highest combustion pressure of 0.9 to 1.2. The combustion pressure difference between the conventional plug and the pre-chamber spark plug was not significantly different until around air-fuel ratio 1.5, and the pre-chamber spark plug was confirmed to be higher compared to the conventional spark plug from air-fuel ratio 1.6 or higher. In this study, pre-chamber spark plug was designed and manufactured, and the combustion characteristics of general plugs in combustion using methane were compared and analyzed, and the following conclusions were obtained. First, as characteristics by the hole size, it was confirmed that the flame propagation speed was increased in the order of hole size 2.0 greater than 2.5 greater than 3.0 up to air-fuel ratio from 0.9 to 1.5, and that the flame propagation speed was increased in the order of hole size 3.0 greater than 2.5 greater than 2.0 from air-fuel ratio 1.6 or higher. Second, as a characteristic of combustion pressure, we found that the pre-chamber spark plug was similar in the reach area compared to the conventional spark plug, but the pressure increased in the lean area. Third, in the case of hole size 2.0, the flame propagation speed was faster than the conventional spark plug, but the pressure was lower than the conventional spark plug due to the quenching effect.